Next, we are on to calculations on friction. Now, have an example 1. A force of 20 Newton applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kilograms move on the table. Calculate the coefficient of friction between the block and the table. Now we take the acceleration due to gravity as 10 meters per second squared. Now earlier in our lesson, we've shown that frictional force F is equal to mu Rn, where F is the frictional force, mu is the coefficient of friction, Rn is the normal reaction. Now let's say a force of 20 Newton. Now I will put a 20 Newton here, right? Applied parallel to the surface of a horizontal table is just sufficient to make a block of mass 4 kilograms. Now the coefficient of friction times the mass is what? 4 kilograms. 4 times acceleration due to gravity, 10. Are we there? The normal reaction means the mass times the acceleration due to gravity. So we have here 20 equals to 40 mu. Therefore, what is your mu? Mu is equals to what? 20 over 40, which gives you what? 0.5. So mu is equals to 0.5. Like I said earlier, coefficient of friction is a ratio. Therefore, it has no units. We'll take the second example. It says when a box of mass 45 kg, therefore M is equal to 45 kilograms, is given an initial speed of 5 meters per second. That is U is equal to what? 5 meters per second. It slides along a horizontal floor a distance of 3 meters. That's X. X is equal to 3 meters. Before coming to rest, that means the final velocity V is equal to 0, right? What is the coefficient of the kinetic friction between the box and the floor? They are asking us for our mu, right? Kinetic friction. Are we there? Now we have initial velocity as 5 meters per second. We have our distance as 3 meters. We have our final velocity as 0. Therefore, we can apply the equations of motion. V squared is equal to U squared plus what? 2AX. Now our V is what? 0. Our initial velocity is what? 5. 5 squared plus what? 2, right? Times the acceleration, which we don't know, times the distance. X is what? 3. Are we there? So we take 5 this side, becomes 25 minus 25 is equals to 6A. Are we there? Now, what is our A? Acceleration is equals to what? Minus 25 all over 6. The next example is a metal box of mass 4 kilograms rests on top of a metal surface. What force applied parallel to the surface is required to 1. Just move the box. Move the box with an acceleration of 2 meters per second squared. Take the coefficient of friction between the box and the surface as 0.25 and acceleration due to gravity, G, as 10 meters per second squared. And now, I get the friction equation as F is equal to mu Rn, where the frictional force is equal to the coefficient of friction, and then the normal reaction is the mass of the substance or the object times acceleration due to gravity. Are we there? So that will give us F is equal to coefficient of friction is 0.25. 0.25, right? Times what's the mass? The mass is 4 kilograms, right? Times 4. Now the G, acceleration due to gravity, is 10 meters per second squared times 10. This will give us the frictional force as equals to what? 10 Newton. 10 Newton. That's for I, right? Now for II, we require the force that will move the box with an acceleration of 2 meters per second squared. Now the force is F is equals to the force used in overcoming friction, which is mu r n plus what? The force of the mass and times the acceleration, right? The force causing acceleration. Now this gives us the frictional force. I'll put it F is equals to, which is what? 10, right? Plus, what is the mass? The mass is 4 kilograms times 4 times, they said the body moves with an acceleration of 2 meters per second squared times 2. Now, if we evaluate this, we get 10 plus what? 2 times 4, which is 8. Now we have 10 plus 8, which gives us what? 18 Newton. Are we there? That's quite. The next question, the next example is a horizontal force of 40 Newton, right? Applied to a box of mass 10 kilograms is just sufficient to move it. Now, if the box is now pulled at an angle of P equals to 30 degrees to the horizontal, find the force required to move the box over the horizontal. Now again, we know that the force F is equal to what? 40 Newton. And the box, the mass of the box, M, is equal to what? 10 kilograms. Alright? We can put in the friction equation as F is equal to what? Mu Rn. Are we there? Where the frictional force is what? 40. Alright? The coefficient of friction, we don't know. Times the normal reaction is 10 times what? 10. Alright? That gives us 40 is equal to 100 mu. Alright? Our mu, therefore, equals to 40 divided by 100. What would that give us? Mu is equals to 0.4. Are we there? Now, they said the box is now pulled at an angle of 30 degrees to the horizontal. Now, if I sketch, let me sketch the force diagram here. Are we there? Now, this is the horizontal floor. All right? Obviously, the weight of this body will act downwards. Are we there? The normal reaction will act upwards. Are we together? And then we are told that this body is pulled by a force, all right, P, which is inclined at an angle. Let's represent the angle by theta. Are we there? So that if we resolve, now if this body is moving this towards the right, the force of friction will act towards the left in opposition. All right? Now that force will be mu Rn. Are we together? Now if I resolve this force P into two component directions, one vertical, all right, and the other horizontal. Now I will call the horizontal force as P cos theta, whilst I will call the vertical component of P as P sine theta. Are we together? Now we can proceed to resolve these forces horizontally and then to sum them vertically. Now let's see. If we resolve horizontally, resolving horizontally, right? We have the system of forces as, let's see, we have horizontal force, we have mu, Rn going towards the left is equal to what? P cos theta going towards the right, right? I balance this force, Rn, with this force, P cos theta. Let's call this equation number 1. Are we there? All right? Now, let's resolve vertically. Resolving the forces vertically. What do we have? We have these two forces going upwards. I have Rn, right? Plus what? P sine theta, all right? It's balanced by the weight acting downwards. It's equals to W, all right? Now let's call this equation number 2. Are we there? Now, from equation 2, can we make Rn the subject of the formula? So I will say from 2, we have Rn is equal to W minus P sine theta, all right? Rn, I'll take P sine theta to go and meet W. So it becomes minus, it's plus here. So I have W minus P sine theta. Let me call this equation number 3. All right? Now let us solve 3 in what? In 1. What would we having? Are we having mu Rn? We've been able to find out that our Rn is W minus P sine theta. So I'll put it here. W minus P sine what? Sine theta. I'll close the bracket. Are we there? Is equals to what? P cos theta. Are we together? Okay. Let me open up the bracket. Mu W minus mu P sine theta is equals to what? P cos theta. Let me bring the P terms together so I can factorize P. Now having mu W is equals to P cos theta plus mu P sine theta. What I just literally done here is to leave mu W here and carry minus mu P sine theta to this side. So it will become P cos theta plus mu P sine theta. Now P is common. I will factorize that. So I will have mu W is equal to P, then open my bracket, cos theta plus what? Mu sine theta. Are we together? All right? So I can now find the force P required to pull this body. Will be P is equal to mu W all over cos theta plus what? Mu sine theta. That gives me the equation required to pull this body towards the right. Are we there? Let us substitute the values of our the constants we have here. So I will have P. Now we've been able to find the coefficient of friction as 0.4. So I'll put 0.4 times the weight. The weight is, we said the mass was 10. So 10 times G will give us 10 times 10. 10 times 10. All over. Now, the force P was pulling this body at an angle of 30 degrees. So I'll put cos 30 plus our coefficient of friction, which is 0.4, 0.4 times sine 30 degrees. Of course, you know sine 30 degrees is equal to 0.5. Now, this will give us P is equal to, now I have 0.4 times 10 will give me 40. Are we there? Now, if we evaluate this, cos 30 plus 0.4 times sine 30, it will give us 1.066. 1.066. So if we evaluate this, it will give us 37.5 Newton. That means our P is equal to 37.5 Newton. Are we there? Now look up. We said if the box is now pulled at an angle of P equals to 30 degrees to the horizontal, find the force required to move the box over the horizontal. Now, whether or not you like it, this force P sine theta tends to lift this box off the ground. Now, P cos theta, this force, is the force required to move this box over the horizontal. So I'm having my P as 37.5 Newton. So I'll put the P cos 30 degrees. Therefore, if I put our force F is equal to P, which is 37.5 Newton, times cos 30 degrees, cos 30 degrees. So if we evaluate this, we'll come up with 32.5 Newton. 32.5 Newton. Most students, when they work these problems and arrive at P, all right, they will put the answer as 37.5 Newton. But you've not literally answered this question, because it said if the box is now pulled at an angle P equals 30 degrees to the horizontal, find the force, look at it here, underline factor, find the force required to move the box over the horizontal, all right? Now the force required